Hi everyone, we're going to do this continuity foldable. So everyone you need one of these, and let's see, I think it's like a tri-fold. So we're going to fold this here, see that? And then this is going to fold over here. Now I like this one because it has the definitions that you need to have memorized. Here, 1, 2, and 3. So definition of continuity is that a function f of x is continuous at the point x equals c, so c would be a number, if the following 3 conditions are met. So all 3 have to be true. F of c is defined, and you need to be able to write it like that, or you could say f of c exists, but what that means in your head is there is a point. Okay, there's a point. Instead of a hole, there's a point. Let me zoom in a little bit. Number 2, the limit exists. So that's what we've been talking about, the limit from the left equals the limit from the right. And so there's no break or asymptote. So that could be like that or like that. Okay, the limit from the left equals the limit from the right. Then the third condition is that the limit equals the point. So the point has to be in the hole. And now what does that mean? That just means it's continuous. Okay, so it's kind of funny we're defining it's continuous, but really when something is continuous it's not very interesting. It's only interesting when it's discontinuous, when there's a hole, a break, or something like that. But we actually define it as continuity. All right, let's see what this foldable is all about. I got these cords in my way. Oh no, no, look what happened. Look what happened. The words got cut off. Okay. Shapoopy. Okay, that's okay. We're going to work with it, you guys. I already made the copies. Explain in words why the graphs on the left are not continuous at the indicated point. Here we go. Number 1. Why is this not continuous at -1? Okay, if you say there's a hole, that's wrong. That's not calculus. Remember, calculus, we have to use the calculus language. This is learning a new language. So we're going to say in a complete sentence, not continuous at x equals -1 because, is that how you spelled because this morning? Now, which one of the 3 reasons? Is there a point? Does limit exist, or does limit not equal the point? So the limit exists, but there's no point. So we have to use this. So instead of saying f of c is defined, we're going to say f of, now what is c? We're not going to use c, we're going to use -1. F of -1 does not exist. Okay, I feel like you guys can't see that. I need to switch pens. I think I have a darker blue to use. Let's try this one. Okay, number 2. Obviously this is not continuous at 2, but you have to write why. So this isn't that a little bit better? Yes, pen, better pen. Not continuous, not continuous at x equals 2 because, what's the reason here? Is it reason number 1, 2, or 3? So it's reason number 2. The limit does not exist because, do you see the break there? Because the limit, okay, ready? This is going to be, you're going to practice your form. The limit as x approaches 2 of the function, you don't put f of 2, you put f of x, does not exist. Okay. Reason number 3. Is there a point? Yes. Is there a limit? Yes. Does the limit equal the point? No. So not continuous. You could also write discontinuous, not continuous because, oops, I didn't write at x equals 4, not continuous, at x equals 4, because, ready for the reason? The limit, this is what you need to practice, this has to be exact. The limit as x approaches 4 of f of x does not equal f of 4. There's no other way to write that. You have to write it like that. The limit as x approaches 4 of f of x, of the function, the curve, does not equal the point at 4, f of 4. Okay, so there's a little practice. That could actually be like the introductory lesson right there. Now, what is going on here? Open it up. Write the letter or attach a graph that does not meet condition 1. Okay, so you should also have this, and I didn't forewarn you, you need scissors and glue. Okay, so out of these, which one does not meet condition 1? So condition 1 says f of c is defined. Oops, I'm out of focus, you guys. I apologize. Sorry, there you go. So which one of these graphs has a point that doesn't exist? Okay, so where are my scissors? Look at the graphs here. Which one has a point that doesn't exist? Well, if you go here, well, this does have a point right there. This has points, this has a point, this has a point. So which one has a point that doesn't exist? So right here, do you guys see that we have vertical asymptotes right here? So this one, f of pi over 2, does not exist. And then right here, do you see this asymptote at 4? So we're going to say B and D go in that first spot. So we're going to cut these out, and to make them fit, I'm going to kind of trim them. Do you see how it says domain? We don't really need that. Do you see how I just trimmed that? Excuse me. And trim. We just want to know that we want to show where it doesn't exist. So B and D, get my handy glue stick, are going to go right here. Write the letter or attach the graph that does not meet condition 1. Okay, glue, glue. Here we go, B and D. Isn't this fun? What am I down to? About 8 minutes left. Okay, write the letter or attach the graph that meets condition 1 but does not meet condition 2. So condition 1 is that there's a point, but condition 2 means the limit exists, so we have to find one where there's points, but there's no limit. The limit does not exist. So right here, the limit exists everywhere. What about right here at -2? Does the limit exist? No, because there's a break. This one, the limit exists, and then this one we see another break. So we're going to cut out C and F for those. And what did I say? We want to make sure we have the letter F, but we don't really need that domain. So we're going to trim them small. What should we talk about while we're cutting? What are you doing right now? I'm in my classroom. It's before school. It's June. Oh, it's June 1st, 2018. What year are you watching this video? Do you think it'll be around like in 2035, the same video? I don't know, people. You never know. Okay, what else should we talk about? Continuity. This is kind of a, I kind of wanted to cover those letters. This is a funny little unit here. It doesn't feel like we're doing math, right? Because we're actually doing more writing and explaining than like solving math problems. So it's a little different. Write the letter or attach a graph that meets both conditions 1 and 2, but not condition 3. So the point is defined and the limit exists, but the limit doesn't equal the point. Okay, so that would be A, it's all there, and what are we down to? My phones are ringing. Okay, we're gonna trim out E, okay? All right, so I glued E down. Lovely. So what about A? Well, A is continuous everywhere. What do you want to do with A? I don't know, do we have room to put it anywhere else? Let's see. Got a mess here. This is like, I think this is what it would be like to be on a cooking show. I don't think I'd be very good at it. Got all this junk going around. Where can I squeeze it in? Do you know what? I'm gonna do something crazy and put it on the fold. Crazy, I know. And let's just write continuous. So even though it has a corner, continuous, I have to do it. It's continuous. So good job, A. You're continuous. Okay, these are my favorite. This is when you sketch your own graph. I'm going to refold. Is there anything on the notes? Okay. Oh my gosh, these are so much fun, you guys. Okay, we can read this. Yes. Sketch the graph of a function that does not meet condition 1. So condition 1 says, oops, f of c is defined. There's a point. So we're going to graph something. I kind of want you to do this. Why don't you try it? I'm going to wait. Isn't this fun? I'm going to wait. So you try graphing something where there's no hole. So there's no point. We have 2 examples here where there's asymptotes, but what I'm going to do is I'm going to graph something different than these 2, just so you have a 3rd example. Let's see maybe a green marker will show up. So let's say there's a big hole here at 1, 2, 3, 4 at -4, but the graph looks like this. Ms. Keener, are there graphs that look like that? I don't know. So there we are. Did I even draw a function? Yeah, it's a function. So this does not meet condition 1, but in these examples there are asymptotes, and here there's just a hole. All right, sketch a graph of the function that does not meet that meets condition 1 but does not meet condition 2. So what does that mean? That means there's points everywhere, so don't get crazy and leave out a bunch of points, but there's a break in the graph. So we're going to go like a straight line. Let's stop at 1. So if this is open, then it needs to be closed here because we need to make sure that there actually is a point defined everywhere, but the limit does not exist at positive when x is 1. Last one, sketch a graph of a function that meets conditions 1 and 2 but does not meet at condition 3. So that means the limit exists, but there's a hole and the point is somewhere else. So what x value should we look at? Let's look at x equals, how about 3? And then 1, 2, 3. I'm going to put the point here and I'll put the hole down here. And what do we want it to look like? Should we make it look like, how about like a sine graph? Fun. Yes. And what should we make it look here? A line. Okay, there we go. Beautiful. And that's it. So this little review, foldable of continuity, and again, you can put this in your sheet protector for Unit 1, what's already in there. So already in there should be like your limits, and you can put your continuity in here, and then you can put any quizzes, and that's your Unit 1, and we'll do more as the year goes on. Thanks for watching.